of a function. And this can be thought of as the MVT, the mean value theorem for integrals. So let's maybe reach back to MVT, and then we'll use that as our springboard to look at and discover what this average value of a function looks like. So if we go back to MVT, and I think I'm going to copy this really quickly. So I'll have the exact same thing. All right, so we'll look at MVT. And it says if we are continuous, so here's my f of x. We say if f of x is continuous on the closed interval a to b, and f of x is differentiable on the open interval from a to b, then there is some point c, which is in between a and b, such that f prime of c equals f of b minus f of a all over b minus a. There is some point where the slope of the secant line is equal to the slope of the tangent line. So looking at the outside of the curve. Now, with our integration, we know we're looking under the curve. So I'm interested in this portion now, what's in between the x-axis and the curve. So let's think about how do we calculate an average? Let's calculate your GPA, right? Grade point average. So one semester you have a 4.2, next semester you have a 4.4, and then previous semester you had a 5.0. You would take all three of those semester GPAs and divide them by 3. And as you moved on in your high school career, you had more semesters worth of grade point averages, so that would be divided by however many semesters have elapsed. So we're going to think about the same thing here. How do we add up the outputs of our function f of x? Well, we do that by the integral, the definite integral from a to b of f of x dx. This is like our adding here. This definite integral adds all outputs from f of x starting at x equals a through x equals b. Right, but that's not the entire, we don't just add all your GPAs together. We divide by how many we have. So what we would do in this formula is we would divide by the length of our interval. And then that looks kind of clunky, so we wouldn't see this in our textbook written in this manner. We would pull that 1 over b minus a out front of our definite integral, and then have the integral from a to b of f of x dx. And that is the average value of a function, f of x. And just to kind of sum up, the average value of a function f of x is 1 over b minus a. Well, we'll say on the interval from a to b. 1 over b minus a times the definite integral from a to b of f of x dx. And we'll just apply this really quickly in an example. Find the average value of f of x equals x squared on the interval from -2 to +2. So our formula for average value is we are going to take 1 over b minus a times the integral from a to b of x squared dx. So this would be 1/4. Now we're going to find the antiderivative. This time, since I have this out front, I'm going to use double brackets. We know we need the brackets here for our antiderivative lower to upper limit. X cubed over 3. Just do a quick ddx and we are correct. We have 1/4 of 2 cubed over 3 minus -2 cubed over 3. So this is 8/3 minus a -8/3. That would be 16/3. And if I take 1/4 of that, I get 4/3. So the average output or average value of our f of x defined as x squared from -2 to +2 is 4/3.